What if the universe doesn't exist in the way we think until we look at it? Imagine a world where particles can be in two places at once, where objects remain mysteriously connected across light years, and where certainty itself disappears the closer we look. This isn't science fiction, it's quantum mechanics, the most successful yet strangest theory in science. For centuries, classical physics ruled. Newton explained gravity, Maxwell described electricity and magnetism. The universe seemed predictable, almost clockwork. But then, cracks appeared. Why did hot objects glow the way they do? Why did electrons behave like both waves and particles? And why did light, which spreads like ripples, sometimes arrive like tiny bullets? Classical physics had no answers. A new theory had to be born. And that's where quantum mechanics entered. At its heart, quantum mechanics gave us rules unlike anything before. 4 principles stand out. Wave-particle duality. Every particle is both a wave and a particle depending on how we observe it. Superposition. A particle can exist in many possible states at once, only choosing when observed. Entanglement. Particles can share a connection so deep that measuring one instantly affects the other, no matter the distance. Uncertainty. Nature itself refuses to be pinned down. The more precisely you know one property, like position, the less precisely you can know another, like momentum. Now here's the twist. Quantum mechanics isn't just philosophy. It shapes the modern world. Without quantum mechanics, there would be no computers, no lasers, no smartphones, no GPS, no MRI machines. Even the chips inside your devices run only because electrons behave according to quantum rules. And right now, scientists are racing to harness it further, building quantum computers that could solve problems in seconds that classical computers couldn't solve in centuries. But here's the most astonishing part. Even after a century, physicists don't agree on what quantum mechanics means. Is it that reality only exists when observed, as the Copenhagen interpretation suggests? Or do we live in an endless multiverse, where every possibility is realized in parallel worlds? Or maybe reality itself is built from information, not matter? The equations work perfectly, yet the meaning behind them remains one of the greatest unsolved mysteries of science. So what is quantum mechanics really about? It is the rulebook of the microscopic universe, strange, powerful, and endlessly mysterious. It explains the structure of atoms, the chemistry of life, the glow of stars, and the technology we use every day. And yet, at its deepest level, it challenges our most basic understanding of reality. Quantum mechanics doesn't just describe the universe. It dares us to rethink what the universe is. And maybe, just maybe, the biggest discoveries are still ahead.